Hello, everyone. Thanks for selecting this session and joining with me today. Hi. Yeah, it's a pleasure. Actually, it's interesting as well. It's been a couple of years I have started speaking in the conferences around Europe. This is the first time I am speaking in UK, and that too very close to where I live by. So I'm really excited to explore SwiftUI's navigation with you all today. I got some pretty cool stuff. Hope you will like it as much as I do. So before we dive in, a little bit about myself. I am Muralidharan Kathiresan. I work as a senior iOS developer at Bally's. I'm originally from India. It's been 3 wonderful years here in London. Together with my friend Shahrukh, we created shiftpublish.com. It's a bi-weekly blog dedicated to iOS development. That's a bit about me. The idea for today is simple and fun at the time and interesting journey, starting with a bit about navigations in general and its important in mobile apps, overview of challenges faced in SwiftUI's navigation so far, and then introduction to the navigation stack, what are its features and functionalities, a quick demo, hopefully everything works, and then what are the best practices that I can able to share with you when we are trying to integrate navigation stack into your SwiftUI applications. At last, a few takeaways. I also have some surprise giveaways sponsored by Codeco and the Point Free teams. So stay tuned carefully. Let's jump in. Okay, let's take an app without navigation. Can you give me some examples? Can you able to see some apps without navigation? Have you seen so far? Any guesses? Yeah, the last time I think I have seen, I don't know, it's exactly without navigation, calculator in iPhone. That's the on screen app I have used. So almost all the apps we use have navigations, right, at any medium. So navigation, navigation is known to be a backbone of any application we build. What does it do? It's the way the users will get from point A to point B. It also refers how users move through the different sections or views within your app. You might have came across many navigation patterns like tab bar, drill down, flat navigation like sidebar, model navigation, and top bar navigation. Navigation design is all about getting users where they want to go with least amount of friction. So why navigation is important? It results in good user experience. Every one of us need some good UX in our apps, right? It also helps to discover various features and functionalities within the app. Helps users to achieve their goal, like if they want to purchase an item in an e-commerce app or a book a train ticket in the ticketing app. If the navigation is smooth, then the job get done easy and quick. There are a lot of probabilities users may completely abandon your app if they struggle with the navigation. So now we understood why smooth navigation is important. Sorry, it's getting a little late. So now let's come back to iOS. From the release of first iOS version, this timeline helps us to understand what are the different APIs at different times. In the first version, that is iOS 1.0, starting with UI navigation controller, followed by tab bar controller released in iOS 2.0, then split view controller introduced specially for iPad. With the introduction of SwiftUI in 2019, NavigationView was announced to support from iOS 13. Then we have our navigation stack in 2021 supporting from iOS 16. Along with it, Apple introduced split view to support master detail interfaces. So how many of you worked in all the APIs here? Oh, nice. Okay. How many of you worked only in UIKits? I think most of. Yeah, cool. And how many of you worked only in SwiftUI APIs alone? Anyone? Yeah, looks like we have a nice. You are in the correct talk today. Good. So you might not heard any issues with navigation in UIKit so far because of this guy, UI navigation controller. Developers working on UIKit, actually most of us have know about the navigation controller because people who are working in SwiftUI also uses this. So what is it? It's a container view controller. It gives a container to display all your views. It defines stack-based theme for hierarchical navigation content. It is very easy to use, stable, and highly customizable API. The only thing is it allows to show only one child view controller will be visible at a time. One example is a drill down navigation, like you are selecting an item from the search results and then going to its detailed page, then adding it to cart, then checking out the item in an e-commerce application. So navigation view was introduced with the first version of SwiftUI. The idea is pretty same like navigation controller. It is a container view for handling the hierarchy-based navigation. It is a single container API for all the Apple platforms, unlike UIKit had a split view controller for other devices. You can define the modifier to be stackable for iPhone or a column-based for other platforms. It was deprecated in iOS 16. We'll see about that shortly. With Navigation View, Navigation Link was also introduced in iOS 13. They are created to work together. Navigation Link is a SwiftUI component that controls a navigation presentation. You can go to a new destination view by just selecting a navigation link. In iPhone, it pushes the new view into the stack. In other platforms like iPad and macOS, it appears to be in the next column as per whatever is the parent configuration. You can basically control the visual appearance of the link by providing your destination view in the labels closure. So there was no wonder why developers mentioning SwiftUI is not stable and production ready because of this. In SwiftUI's navigation view, starting with limited customization, like missing the pop to root, and then missing one step going back, and then dismissing the entire navigation stack in the middle of somewhere, or if you want to replace some views in between. Totally, the navigation codes adds a lot of complexity in each screen. Sometimes it is buggy and behaves inconsistent across the platforms since it was a common API for all the Apple platforms. It was not suitable for complex patterns. One of the reasons is you need to manage the state explicitly because here the view is binded with the navigation. So it means like navigation always coupled with the view. It makes us tough to manage the state as well as features like state restoration. Yeah. Lastly, when declaring navigation links, the destination view needs to be set. This resulted in creating unwanted instances, even though if we don't need them, all because of the core idea of the SwiftUI. A view is a function of the state. Don't get me wrong, this idea was great, but at the time of introduction of the navigation view, it was not yet that much advanced. So let's see this a little bit in action. So I have a simple SwiftUI app which just lists all the continents, what are the available continents. Then if I tap one of them, I go to one of the countries belonging to that respective continent, and I just go to a detail screen. It will just tell. It's a very simple app just to see. So what I have done is I have the continents view, which is listing continent, and I have a countries list view. That's the one we are listing the countries, and I have the detail view for the detail screen. So I have just added init in the countries list view, which is the second screen, so that we will know when it is getting initialized. The same for the detail view. So if I try to run the application, you will see all the instances for the second screen, which I haven't even opened, is getting initialized. So if you see creating countries list view for Asia, Africa, all the way to South America, everything is getting created. So this is a very simple app. Imagine if you have a very complex application where you need to create all your sub-views, children. So all the views are getting initialized even though you before you use them. So this affects a lot of optimization, right? So this is the one thing. And then second, if you, I have a button like pop to root, if I press that, I need to come back to the home screen. To implement this, I need to use a way called isActive. What this does is it will tell whether the destination view is active or not. So I need to create this property and pass it all the way to the children. So one by one. So I need to pass it is active to the children and then to its sub children to all the way. If I have to come back, so I need to have this much of trouble. Yeah, let's go back. So now what all we saw before were pre-iOS 16 era. Now we have the new powerful navigation stack. Instead of view-based, navigation stack is a data, that is the state-based API for hierarchical navigation. It replaces navigation view and supports from iOS 16. Here you can pop to root, move one step backward, and you don't need to pass the reference of the previous view to the next view to do that. So fancy, right? It looks like a promising start. So to understand navigation stack completely, we need to understand its family members too. First one is navigation path. We just discussed navigation stack is state-based. So that means the state is effectively managed by this navigation path. It is a data structure representing the current navigation state of your app views. Think of like a stack of views, and the navigation path keep tracks of what are the views you have been traversing we can also consider like navigation path represents all destinations. Let's call them nodes in that navigation stack, so it will be easy to understand. In reality, we don't pass the same type of objects to all the screens in your app. So you may have a different custom models at every time. So we have to pass all different types. That's why Apple has created and introduced new type called this navigation type. This is a type allows us to store any type of data, and then with this help of this navigation path, we can append any heterogeneous elements to our path array. Only one requirement is that this whatever item we create in this state, that should conform to the hashable protocol. So next one in the navigation stack family is navigation destination. It is a modifier used within navigation stack to link the path components with their corresponding destination view. You can think of a way like telling the navigation stack which view to display at when. So it works conjunction with the navigation path as we just saw that represents the state. By defining destination based on data types, it supports complex navigation types while maintaining the type safety and clarity. So let's see this in action. So I have the same project again. This time, instead of the navigation view, I'm going to see how we can integrate into navigation stack. The first step I'm going to do is changing it to navigation stack. It has two initializers. One is with the root and the other one is path. Let's first try with. So I have the navigation stack changed. So now I'm going to use the destination identifier. So it needs the hashable type. So here, whatever is my destination I had here, the country list view, I'm going to place it in my destination. So I need the continent type, continent. So I will get the continent object here that I will be passing it to my views. So that's that. So here, this link is now value based. So I will be just assigning the value, which is the continent. So that's it. So we have moved from the previous view. The same way, I'm going to change this in the subsequent views as well. So I'm going to introduce a destination. So here it will be of country type, country.self, and the destination is whatever I had previously inside the navigation link. So that will be a detailed view. So I will get my country here. And this navigation link is just now updated to use the value. value here. So now if we run, we need to see if it's still initialized or that initialization problem is gone away. Yeah. Oh, sorry. Thank you. So now there is no other views getting initialized. So there is no problem. If I navigate back, so it will just initialize whatever is the one I have navigated. So it just worked. So this problem has been solved. That's the first step. So thank you. We have seen we need to pass all this reference of is active to till the end. Let's see how we can migrate this as well. So I'm going to create navigation path as we just seen. The path will be navigation path. So I will be using this path in the child views as well. So here it will be of binding since it is the child view. I can create a navigation path. So just giving it as a default value so compiler doesn't complain. Self.path is my path. So I can able to get it anywhere. So you can use it as an environment object as well, or whichever way you can use it. So I'm just using it here. Oh, yeah, underscore. So in same way, oh, sorry. Yeah, I can simply use this as an environment object. So it will be used. Yeah, otherwise. Yeah, it should be of type binding. Yeah, it should be of constant navigation path. Yeah, so that is done. So I will use it in the last view here. We'll copy the same. So we'll use the same initializers here. So now, previously I was using this active, right? Let me check what is the issue. That is a navigation path. This export is crazy. Yeah, I think so. Just a second. Let's check. Yeah. So here will be path is binding of navigation path. And I just give it as a detail constant for the navigation path. And then here it will be self underscore path. So this is path. So now instead of giving this, I'm going to use this path and I'm going to reset it to the new stack.
Question I have is why are you giving it initial value knowing that will come from the parent?
Yeah, I'm just, yeah, I can, yeah. Yeah, that just to build. Yeah. Yeah, I can remove that also. Anyhow, I know I will be passing it. Yeah. Sorry, the question is what he asked, why we need to pass the initial value. We already know it will be passed. So I can remove this as well. I'm pretty sure it will be passed from this thing. So I have just done this. So we can see if it works here. So it doesn't work because we have used the default initializer. Now I need to use the path. Whatever is the navigation path I created, I will be binding it to my path. So if I have here, I can, yeah. So now I need to use it in my views here. So this is the question you asked. So yeah, I will be giving here, path will be my path. The detail view, if I go to continent and I click, so this works. Yeah, thank you. Yeah.
Is it valid to pass in as as an environment?
Yes.
So you can do that.
Yes. Yeah.
When you need to pass it all the way through.
Yes, you can use it. That's why I told two options are there. So you can set it as an environment object as well, or you can pass it to your child views. Both will save. We will see an environment object example later. Yeah. So this way we have overcome all the two problems we just seen with the navigation view. Yeah. Let's go back. Yeah. So the next one is a navigation split view. It is a container view that represents views in 2 or 3 columns, where selection in the leading column and the presentations will be in the subsequent columns. Navigation split view is perfect for multi-columns app like mails or notes on Mac and iPad. So navigation split view comes with cartload of configurations options that let you to customize the width and the sidebar presentation even programmatically. So finally, I would encourage you to start building applications in your navigation experience with navigation split view when it makes sense, so that if even though you start supporting iPhone, navigation split view will automatically adapt to the narrower devices as well. So and when you are ready to support iPhone Pro Max in landscape mode or bring your app to iPad or Mac, so navigation split view will take advantage of the additional space automatically. We don't have to do any other configurations. So like this, the previous navigation view, whatever we had with the columns, was a single API. Now we have the navigation split view dedicated for the large devices. So let's see this also in a quick action. So I have the same project, what we had before, the navigation stack. Right now, if you run this in iPad, it will be just mimicking whatever we see in the iPhone. So if I run it in the iPad, so it will be exactly same like whatever we seen in the iPhone. So this is not what we need, right? In iPhone, we need to utilize the sidebar and everything. So let's see how we can easily portable. So I'm going to create a navigation split view. So I'm going to use the 3 column here, sidebar, content, and detail. So I will just add whatever I had in the list. This will go entirely to the sidebar, and then my content is a list view. So this will be going to my content, and the detail is my detail view. So this will be going into my detail view. So now I don't need this navigation stack. Now I need 2 of my values here. So to have these values, I'm going to create a property state var selected continent. It will be of type the continent my type. So initially I'm just going to set it as nil, and then I need one more country. So that will be of state var selected country will be of type country. I'm just going to do. So list, you might know that list has a selection property so that we will know whatever is being selected. So first one, I need to know what is the continent being selected. So I'm going to use that to bind the value selected continent, and then so that's done. And then I need to have a so I can use the same state to get the values as well. So if continent equal to selected continent, then I can pass this. You can also use the ELF to show your empty data states. We are just looking on the success scenarios right now. And then I have the selected country. if selected country, if country equal to selected country. Oh, sorry. Thank you. So I'm going to use that. Now there is one more list here in the second screen. So I need to use the selection property here also. Then only it will tell me when to navigate to the detail view. So I'm going to create one more property here, binding. So whatever I had here, the selected country. So I will be manipulating this. So now I get even the second screen, I can able to get it. So we don't need this in it. I'm going to delete this one as well. In the list view. Yeah. So we have our sidebar and the content and the detail. So now I need to pass this selected country, which will be of binding selected country. Let me try to run this in the iPad. So let me put in the landscape. So I haven't added the empty state, so it doesn't show the starting data, but I can use the same view. So let me run the same in iPhone. So we have the same view. If we start using the split view, we can able to get this functionality. So we don't have to manually configure every time. Yeah. So let's go back.
Question: what happens when you tap on the iPad, the hook to root the iPad?
Yeah. So I haven't added currently. So if you want to close the current one, and yeah, the question is like, what happens if you pop to the root in the iPad? So currently, if you don't have to show the detail, okay, if you can show the empty view, it's the first. That's the only option. Otherwise, you can do is if you want to have any other custom views, you can able to denote it. The action only happens when you select something in the sidebar and to this detail. Yeah. Yes, correct. Yeah. Thank you. So now, what is the need for navigation stack? Almost all the navigation methods that we discussed above were triggered using a user action or a button click. But there are many situations we need to handle these navigations programmatically in a asynchronous manner. As an example, let's say I need to hit a API call, and after I get the response, I need to move the user to next screen, something like that. So SwiftUI has provided an extra argument in the navigation link to achieve this purpose. And on many occasions, we need to handle our navigation outside of the views, even not even programmatically inside, outside of the views, such as loading from deep links and responding to asynchronous event. By the way of separating the views and whatever is the navigation logic, we can achieve this programmatical navigation also, and we can manipulate the state from outside of the views as well. Another sorry, yeah. Another bonus of using navigation path is the codable representation of the pushed values. The navigation path provides the codable property of type codable representation, allowing us to encode pushed values into the data type. What it means, like with the use of the codable representation, the navigation path, we can save our path, and then whenever if the apps gets killed or it goes to the background, when he comes back, we can able to persist the navigation stack itself. Yeah, that's the major advantage. Yeah, at the last demo, let's see how these things are there. So with the previous demo in continuation, I'm going to create a class called the router. So I have two navigation as we've seen here. One is in the continents to countries and the countries to destination. So I'm going to add a enum called the route, which will help me to have these two cases. One is the continent of the type continent and the country of type country. So I can able to, and then I have created a property here, a computer property, which will basically give me that particular view whenever that value is being initialized. So I can get the contest list view here and the contest detail view here. And I have confirmed to the hashable to use it as a navigation path, and I have confirmed to codable to use the codable representation, so I can able to save this. So I'm going to create the router. So this is my router class, which is an observed object. So basically it holds the route array. So the route array is the one we just created, which will have all my destinations. So with the help of this routes, whenever it gets manipulated, I am saving this complete path in the documents directory. So with that, I have created 4 methods. One is to push new screens, whatever is my destination. And if I want to go back, I can go back in that array. Or if I want to completely reset my navigation path, I can reset it. If I want to replace one or replace the stack as per my current requirement, I can able to do that. Let's see how we can add this here. So I'm going to create an state object this time, where my path is router. So let me name it as router. So here, as per the previous question, I can use it as an environment object. I'm going to use this router. So I'm going to change whatever is my value. Now my value should be route.route. Route.continent. So I'm going to use the continent here, destination. So my values changed, and for that corresponding navigation, I'm going to use my route type. So now we don't have to manually create all this because we have created in our property itself. So I can just use $0. So I will get the destination view easily. I don't have to manually. What are the cases I will be having the values? Here it is only one. I can have multiple. So, but that destination will automatically be appended. So I have my navigation destination sorted and this thing. So if I want to use the same here, I can use an environment object here, which will be of type router. Yeah. So I can use route.self the same way. I can just use a $0. And here in my value, it goes to route.country. So that's it. So I can easily use. So in the last screen, we have a requirement about setting this. So I have created a method so that I will just use router.reset. So I just want to go to the reset and go to the root screen. So that's done. Let's see if this works. So it just navigates to the next screen. And if I click on the pop to root, I just need to see here, I need to change the path because I have created this router path. So it will be router.routes. Oh, sorry. Yeah. Thank you. So you can basically create any option. If I have to create something like pop one step back, so I just need to do router.go back. So I can pop one step back. If you have to push, you can easily maintain this pattern as per your child views. Yeah. So there are many patterns introduced in the community for handling apps navigation. So one pretty common one is router, the one we just saw. It is also called a enum navigation or navigator pattern. As you've seen, it's easy to use, keeps the navigation code away from the view, and serves the purpose. Second one is coordinator pattern. This is the widely used one with UIKit also. This can be adapted to SwiftUI as well. Here, how it applies is, it decouples the navigation uh, by using a coordinator object that manages the navigation flow for your specific part of your app. Coordinator also is easy to test the navigation logics if we have to do, and then reusability of these coordinators can be used in the different part of the app. So the third one is a specific type of coordinator pattern called a flow coordinator pattern. What it does is it almost inhibits all the characteristics from the coordinator pattern, but you can create child coordinators for that particular flow, like your settings flow. You can have your future 1 and the future 2, like that. And then there is one more other common pattern in React applications is container presentational pattern. There are similarities always between React and SwiftUI because both are state based. So this one I haven't used personally, but I just added for a FOA kind of thing. This is also now started using in the SwiftUI application if you want to manage the navigation better. So we have seen all the good things, right? But there are few limitations as well. So in NavigationStack, and it's our duty to share what are the limitations also. Root view here is not part of the navigation stack like we had it previously. We can add and operate views on top of the root. That doesn't mean we can get the root view control and we can work on it. So that's one thing. You can't do multiple operations on navigation stack, like if you want to pop one and push view at the same time, that is not possible. And the navigation stack doesn't provide built-in method to navigate back to a specific view in the stack. You can only pop to the previous one and push the new one to the next one. And it doesn't directly support tab view. I think one of your question was somebody was adding in the split view, right? So people were using separate navigation stack under tab views also. So it doesn't have a direct support for tab view. And then there is no support for model and sheets and popovers. So we need to use their custom properties to use them. Navigation stack provides limited customization options for navigation bar as well. You can't directly change the back button title or images. And animations are terrible sometimes. So you need to handle them carefully if you are personally using. Yeah. So that's it. Now we have seen all the navigation APIs, right? You might have a question like navigation controller supports both the UIKit and SwiftUI. Why can't you use either navigation controller itself? You can use it. It's up to the team. If you still have a large part of your code base in the UIKit and if you want to maintain that, it's okay to use. You need to understand navigation controller is an imperative one and SwiftUI works on the declarative concept. Navigation controller, it's not created for SwiftUI, but you need to understand what are its different when you are using. And then UI navigation controller is not type safe, but the navigation stack which we just seen, it's a type safe one by using the navigation path. And navigation stack only supports from 16, whereas navigation controller supports from 2.0. These are the ones you need to consider. Yeah.
But under the hood, I think navigation starts with you in your view controller, right?
Yes. Yeah. So what are the takeaways here? Remember, navigation stack is value based. So that value should conform to hashable, as we've seen, to make it heterogeneous. Placements are very serious, like how we design the view. So destination modifier should be inside the stack. Otherwise, it won't get triggered and you can't able to go to your destination views. And the top level will override the lowest one of the same type. So that also we need to be considered. And do not put your destination modifiers on a lazy stack like lazy V stack. So there are sometimes it doesn't get initialized and you can't get your results easily. And then we have seen our router pattern, right? Never define your router objects in the app level. So you might have multiple scenes sometime for specific requirements. So if you start creating your router in the app level, then it will be little delayed or you will have inappropriate results. So start having in your root views, not on the app level. So that's one major thing. And then as we seen before, if it is okay to use split view, start using with split view so that you can adapt to the larger devices. And select a navigation pattern whichever suits your team and your project well, so that you can keep the navigation logic always outside of your view and you can easily testable and reusable. So also consider using SwiftUI's navigation default accessibility support, to get better accessibility support as well. Cool. That's it. Thank you. Questions? Yes.